Let us look at another example of network analysis. In this example, we have been given the activities in a different format. For example, the first activity, which is 1 to 2, the second is 1 to 3, and so on. So what this means is that the first activity 1 to 2 means that this is the activity which is from node number 1 to node number 2. So this is the activity, and for this activity the duration has been given as 4 days. So this is 4. Similarly, 1 to 3 has a duration of 6 days. So from first node, the activity going to the third node has a duration of 6 days. Now we are being asked to draw a network diagram, obtain the early and late start and completion times. That means we have to find the early start, early finish, late start and late finish times, and then determine the critical activities. Now critical activities are the activities which are on the critical path, and if we delay any of these activities, then it will impact the overall project duration. So let us first draw the network diagram, and then we'll find out the early and late start and completion times, and then from there we will determine the critical activities. So first is node number 1, and node number 2. Now we'll draw the activity between these two nodes, and the duration has been given as 4 days. Next activity is 1 to 3. So let us draw node number 3. Now let us draw the activity between these two nodes, and the duration for activity 1-3 is 6. So here we have completed 1 to 2 and 1 to 3. Now next is 2 to 6. So let's draw node number 6. Now let's draw the activity between these two nodes, and the duration is 8 days. So we have completed 2 to 6. Next is 3 to 4, and if we look at the next activity is 3 to 5. So it is sometimes beneficial to just look at the subsequent activities so that we know how many activities are emerging from one node, and that helps in drawing these activities. So let's first draw 3 to 4. So we'll draw 4 here, and this is the activity which has a duration of 7 days. So we have completed 3 to 4. Next is 3 to 5. So let's draw 5, and this is the activity 3 to 5 which has a duration of 4 days. So here we have completed 3 to 5. Next is 4 to 6. So this is 4 to 6 which has a duration of 6 days. Next is 5 to 6. This has a duration of 5 days. Next is 5 to 7. So let's draw the node 7. And now we'll draw the activity 5-7, which has a duration of 19 days. Next activity is 6-7. This has a duration of 10 days. So now we have completed drawing all the activities and we are showing the duration of each of these activities. So next step is to find out the early start and early finish times. So let's start doing that. So the first activity is 1-2. This doesn't have any preceding activity, so this can start at the 0th instance. So it can start at 0 and it has a duration of 4 days. So the early finish would be 4. Activity 2-6 has a duration of 8 days. Now activity 2-6 can only start once the activity 1-2 has been completed. Now 1-2, the earliest finish time is 4. So 2-6 can start only on the 4th day and it has a duration of 8 days. So 4 plus 8, which is 12. So 12 becomes the early finish time. Activity 1-3, this can also start on the 0th instance because there is no preceding activity and it takes 6 days, so the earliest finish time would be 6. Activity 3-4 can start only after 1-3 has finished and the earliest finish time for 1-3 is 6 days. So activity 3-4 can start on the 6th day and it takes 7 days to finish activity 3-4. So 6 plus 7, which is 13, is the earliest finish time. Now for activity 3-5, this activity can start only after activity 1-3 has finished. Now activity 1-3 will finish on the 6th day. So activity 3-5 can start only after that and it takes 4 days. So 6 plus 4 is 10. So 10 becomes the earliest finish time. Activity 4-6 depends on the completion of activity 3-4. Activity 3-4 finishes on the 13th day. So activity 4-6 can start only after that and it takes 6 days to finish this activity. So 13 plus 6 is 19. So 19 is the earliest finish time for activity 4-6. Now activity number 5-6 has a duration of 5 days. This activity can start only after activity 3-5 has finished. Now activity 3-5 finishes on the 10th day. So activity 5-6 can start on the 10th day and it takes 5 days to complete activity 5-6. So 10 plus 5 is 15. So 15 becomes the earliest finish time for this activity. Now for activity 6-7, there are 3 preceding activities, which is 2-6, 4-6 and 5-6. So activity 6-7 can start only after all these 3 activities has finished. So we have to take the latest of the earliest finish time between the 3 activities. So 12, 19 and 15. So activity 4-6 finishes on the 19th day, which is the latest amongst the 3 activities. So activity 6-7 can only start after 4-6 has been completed, which is on the 19th day. So the early start time is 19 and activity 6-7 takes 10 days to complete. So 19 plus 10 is 29. Now activity 5.7 can start only after activity 3.5 has been completed, which completes on the 10th day. So activity 5.7 can start on the 10th day, and activity 5.7 takes 19 days to complete. So 10 plus 19 is 29. So earliest finish time is 29. So here we have completed the earliest start and earliest finish time for all the activities. Now since the earliest finish time for the end activities is 29, we can say that the duration of the project is 29 days. Now, keeping the duration as the same, that is 29 days, let us now calculate the latest start and latest finish time for all the activities. So let's start from activity 6.7. So the latest finish time is 29, and 29 minus 10, which is 19, this becomes the latest start time for this activity. Similarly for activity 5.7, the latest finish time is 29, and 29 minus 19, because this activity will take 19 days. So 29 minus 19 is 10. So 10 becomes the latest start time for activity 5.7. Now coming to activity 2.6. So the following activity is 6.7. So for 6.7, the latest start time is 19. So activity 2.6 has to be completed latest by the 19th day, so that 6.7 can start on the 19th day. So start time for activity 2.6 become 19, and it takes 8 days for activity 2.6 to complete. So 19 minus 8, which is 11. So 11 becomes the latest start time for activity 2.6. For activity 4.6, again the activity 6.7 can start only after 4.6 has been completed. So if activity 6.7 has to start on the 19th day, activity 4.6 should latest be completed by the 19th day. So 19 becomes the latest finish time for activity 4.6, and 19 minus 6, which is 13, this becomes the latest start time for activity 4.6. For activity 5.6, again the same thing. 6.7 is the activity following this activity, and activity 6.7 has to start latest by the 19th day. So the latest finish time for activity 5.6 becomes 19, and 19 minus 5, which is 14, becomes the latest start time. Now let's take activity 3.4. So activity 3.4 is the preceding activity for 4.6. Now for activity 4.6, to have the latest start time of 13th day, activity 3.4 should be completed by the 13th day. So the latest finish time for activity 3.4 becomes 13, and 13 minus 7, which is 6, becomes the latest start time for activity 3.4. Now for activity 3.5, there are two activities following this. The first one is 5.6 and the second one is 5.7. So activity 3.5 should have been completed before any of the activities, that is 5.7 or 5.6, can start. Now 5.7 has to start on the 10th day, and 5.6 has to start on the 14th day. So activity 3.5 should be completed by the 10th day for activity 5.7 to start. So the latest finish time for activity 3.5 is 10, and it takes 4 days to complete 3.5. So 10 minus 4 is 6. This becomes the latest start time. Now for activity 1.3, again there are two following activities, which is 3.4 and 3.5. So activity 1.3 should have been completed before 3.4 or 3.5. Any of these two can start. Now the latest start time for both these activities is 6. So this becomes easy. So because both are 6, the activity 1.3 has to be finished latest by the 6th day for any of these other activities to start. So 6 becomes the latest finish time, and it takes 6 days to complete 1.3. So 6 minus 6, 0. So 0 becomes the latest start time for this activity. Now for activity 1.2, 2.6 is the following activity, and 2.6 has to start latest by the 11th day. So 1.2 has to finish by the 11th day. So 11 becomes the latest finish time, and 11 minus 4, which is 7, becomes the latest start time for this activity. So at this point we have calculated the early start, early finish, and latest start and latest finish time for all the activities on this project. Now the next step is to determine the critical activities. Now the critical activities will be the activities on the critical path which cannot be delayed. So one method of finding the critical path was to calculate the durations of each of the possible paths from the starting node to the end node of the project, and whichever is the longest path becomes the critical path. Another way is to determine if the earliest start and latest start is the same, along with the earliest finish and latest finish being the same. So if both the sets of duration is the same for an activity, it may fall on the critical path. So let us determine these critical activities and then see if they are on the critical path. So let's start from activity 1 to 2. So for 1 to 2, the earliest start time is 0 and the latest start time is 7. So of course these two are not matching, so this activity is not on the critical path. So definitely there's no point calculating the activity 2 to 6, because the critical path has to start from the starting node and has to end at the last node of the project. So let's take the other path, which is 1 to 3. So now for 1 to 3, the earliest start time is 0 and the latest start time is also 0. So this is good. Now the earliest finish time is 6 and the latest finish time is also 6. So both these set of numbers match. So this is on the critical path. So let's put a red dot here indicating that this is on the critical path. Now let's take activity 3.4. So earliest start is 6, latest start is 6, earliest finish is 13, latest finish is 13. So this looks like a critical activity. 4 to 6, earliest start is 13, latest start is 13, earliest finish is 19, latest finish is 19. So both the set of numbers are the same. So this is on the critical path. Activity 6 to 7, earliest start is 19, latest start is 19, earliest finish is 29 and latest finish is 29. So both the sets of numbers matches. So this also is on the critical path. So we have this set of critical activities starting from the first node and ending at the last node. which is 1, 3, 3, 4, 4, 6 and 6, 7. So this becomes the critical path 1, 3, 4, 6, 7. Now let us also evaluate the other path. So 3 to 5, for this activity the earliest start time is 6 and latest start time is 6. The earliest finish time is 10 and the latest finish time is also 10. So both the sets of numbers matches. So this also is a critical activity. Now activity 5, 6, this has a earliest start time of 10 and latest start time of 14. So this does not match the criteria. The other activity is 5, 7. So this also meets the criteria. So this is also a critical activity. So this also gives us another path. So 1 to 3, 3 to 5 and 5 to 7. So in this case there are two critical paths 1, 3, 4, 6, 7 and 1, 3, 5, 7, and the activities which we have marked in a dotted line are the critical activities. Another very interesting observation is that let's take the case of activity 4 to 6, which is of 6-day duration. Now suppose we delay this activity by 1 day, so the duration becomes 7 days. So what that will do to the overall project is that the overall project will get delayed by 1 day, that is it will make the duration from 29 to 30. But along with that, what will happen is that the other activities, which is 3 to 5 and 5 to 7, will no longer be on the critical path, because the path 1, 3, 3, 5, 5, 7 will still have a duration of 29 days, but the path 1, 3, 3, 4, 4, 6, 6, 7 will have a duration of 30 days. So this is how the project durations changes, and that is how the project manager controls the duration and the schedule of the project.